Hi there. In this video, we'll be converting the standard form of an ellipse, which is given by ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, with a and c not equal and both positive. We'll be converting this into its ellipse form or ellipse equation form, which is given by x minus h squared over a squared plus y minus k squared over b squared equals 1. So we'll be doing this since we know that in ellipse form there are a lot of nice properties and it is easier to see certain parts of an ellipse as well as graphing it. To do this, we'll be utilizing the concept of completing the square. So if you can't recall what completing the square is or how it works, I can link a video or I can put a link around in this video regarding how to do the completing the square. So without further ado, let us have this example. In here we have x squared plus 4y squared minus 4x plus 24y plus 36 equals 0. Before we convert this into its ellipse equation form, feel free to pause the video so that you may try to work on this example first on your own. Good, so to start, what we can first do is we can move this constant 36 to the right hand side of the equation. So that would give us x squared plus 4y squared minus 4x plus 24y equals negative 36. And from here, we'll be grouping certain terms together. We'll be grouping the terms with the variable x as well as the terms with the variable y. So in doing this, we'll have here x squared minus 4x in the first group and 4y squared plus 24y in the second group. Observe that I put a blank space out here since, again, we'll be applying completing the square. So we need this blank space area, which will fill up later on when we complete the square. But before that, observe that in this second expression, second group, we have a common factor of 4. So we can factor that out of the expression or the group. So we'll have this. This time, let's try to complete the square, starting with the first group. So if you can't recall how to do the completing the square, I'll try to explain the process here slowly. So essentially, our goal here is to convert this out here into a perfect square trinomial so we can easily factor it into the square of a binomial. The trick here is to focus on the coefficient of the middle term, which is negative 4. What we do with this one is we divide this by 2. So negative 4 over 2, that would give us negative 2. We square this one, and that would be the value of this one would fill up this, or what I mean by that is we'll have here 4. So we have completed the square for this first group, which is clearly a perfect square trinomial. Now let's move on to the next group. Oops, I forgot that. Again, if we complete the square on one hand side of the equation, since we add 4 out here, we must also add 4 on the right hand side. So take note of that one and don't forget that one, like what I did. Let's now move on to the second group, this one. For this one, again, we focus on the coefficient of the middle term. So we have here, we divide this by 2, so we have 6 divided by 2. This will be 3. Take the square, and that would be our last term. 3 squared is equal to 9. So this out here is now a perfect square triangle. And again, like what we did out here, since we add 9 out here, we add 9 as well on this side. But not so fast. Don't forget that we have a 4 out here, which means that what we actually add on the right hand side is 9 multiplied by 4. So we have here 4 times 9. And so this is now the completed form, or the form wherein we had already applied completing the square. This part out here is the crucial step in obtaining the ellipse form from the standard form equation. So now, next thing to do is let's simplify. For the right hand side, start with this one. Take note that 4 times 9 is equal to 36. So the 36 out here would cancel since this one is negative and this one is positive. So we'll be left with this one, which is 4. And for the left hand side, take note that for this one, this is equal to x minus 2 squared. And this one out here is equal to 4 times y plus 3 squared. So we'll obtain this. Now we are close to our desired outcome. The only thing that's left is recall that in ellipse form equation, the right hand side must be equal to 1. So we need to find a way to make this become 1. And one of the things that we can do, which is actually the best thing that we can do out here, is we can divide 1 over 4, or we can divide 4 rather, or multiply 1 over 4 in both sides of the equation. That would give us x minus 2 squared over 4 plus y plus 3 squared equals 1. And notice that this one is already the final answer, since this guy out here is already in its ellipse form equation. So that completes our solution for this exam. If you want to take a screenshot of this one, you may do so. Just wait a minute, we'll have this. There. So this is the complete solution on how we converted this standard form equation into its ellipse form equation. So I hope you got that process correct. Again, the crucial step out here is this middle part out here, the completing the square part. So good. To end this, here's an exercise that you can work on. We have here x squared plus 3y squared minus 6y minus 6 equals 0. Your goal out here is to convert this into its ellipse form equation. So you can check the example earlier, since the process is just similar. So yeah, that's it. I hope you enjoyed and learned a lot from this one. Feel free to comment down below if you have any suggestions, recommendations, or comments, whatever comments you have for this video, this playlist, and this channel in general. So yeah, that's it, and that's all for this video.